Hey everyone. I'm Don, and I am a developer relations engineer on the Android team at Google. And I'm here to talk to you about Jetpack's new library, Navigation 3. And since going through a bulleted list of features is kind of boring, I've stupidly decided to live code everything that I talk about today. So my colleague just informed me that I haven't made any sacrifices to the demo gods. So let's see how this goes. OK, but before I get into that, let's start with a question. Why Navigation 3? Now, some people might say it's because we got it wrong the first 2 times. But I say those people are not only mean, but also incorrect. Because the first library that we launched was back in 2018, and a lot has changed since then. So the way that apps have been architected, tested, and most importantly, the way that their UIs are built has massively changed in the last 7 years. And much of this has been driven by Jetpack Compose. So a big part of Navigation 3 was to build it from the ground up with Compose State as a fundamental building block. This means that it fully buys into the declarative programming model. You change the state that you own, and Nav3 reacts to that new state. Nav3 also takes a less opinionated stance on a lot of the functionality, especially compared to Navigation 2. Instead of having behavior embedded into the library itself, we're providing how-to recipes with hopefully good defaults. And while we know that good defaults might get most of you most of the way there, our #1 goal is to get out of your way. And the idea is that every feature we provide is just a simple combination of lower-level components. So if you don't like the way that we implemented something, you can always drop down a level, and instead of changing your mental model, you can just swap out our code with your own implementation. OK, so that's a lot of talk without actually seeing any code. So let's switch to Android Studio to see the actual Nav3 API. OK, so what I'm going to do here is I'm going to start with a very basic project that doesn't use a navigation library. So to be clear, we're not using Navigation 2 or anything else, just normal Compose types and APIs. And the idea is to start with the most basic navigation system possible so that we can focus on the fundamental principles. Hopefully, you can then map these principles to whatever navigation library you're currently using to see whether Nav3 is a good fit for you. And because I work for Google, obviously I'm building a chat app. So here's the app running on the emulator here, and we have a list of conversations on the first screen, and if I tap on one of these conversations, you'll see we open Chrome, which is not what I wanted to do. So hang on, let's go back. I'm having to do all the live code on this monitor, not this one, so it's kind of a little bit of a challenge. But we have, so we have the conversation here, and if we go back, we can see the conversation list. So this is all pretty standard stuff. So this is our main activity here, and although it might not look like very much code, it actually has a lot of the building blocks that we need for a navigation framework. So let's just talk through this briefly. We have some routes at the top here, which are used to identify the screens in the app. So conversation list is just a data object. And we have a conversation list data class, which has an ID to identify the conversation. So inside our main activity, we have, let me just move this over, we have a backstack, and this is just an observable list. So it's a list which is backed by Compose state, and on it we have one item, which is our home screen, the conversation list. So let's get into the rest of the code, which is we have a box, which might seem silly, but it's just a container which is going to render content for us. Inside our box, we read the last element from the backstack, and that gives us the current route. And then we have this when statement, which compares the current route with each type. So for conversation list, we return the composable content for the conversation list route, and do the same thing for conversation detail. Navigating is as simple as just pushing an item onto the stack. And up here, you'll see we have a back handler, which when it completes, removes the last item from the stack. So this way we can navigate forward and we can navigate back. So these are kind of some of the fundamental building blocks that you need for a navigation framework. The thing is, there are a couple of things missing. So you'll notice that when I tap on the conversation screen, there's no animation between these screens. The other thing we're missing is the ability to save state. So when one of our screens is removed from the composition, we lose all of the state associated with that screen currently. And these are kind of fundamentals for any decent app. So luckily, with the help of Nav3, we can solve these problems and do a bunch of other cool things as well. So let's get into the Nav3 API now. So the first thing we can look at is our backstack. Now, Nav3 doesn't care what you use for your backstack, what types you use. So actually, we can just keep this code exactly the same. We do need to change this box, though. And one of I guess the main UI component that Navigation 3 provides is called a nav display. So we'll just change this to a nav display. OK. And so the nav display takes a few parameters. Number one, it takes a backstack. And if it would let me complete, then there we go. OK, so this is the nav display directly observes your backstack and gets recomposed whenever it changes. The other thing that nav display has, it has a built-in on-back handler. So we can just use our lambda that we had before in our back handler. We can just move that into our nav display here. And we can get rid of our back handler. OK, so it looks like we have a lot of code not compiling here. And for once, I actually know what the problem is. We need to make some changes to nav display's trailing lambda. So I'm going to switch back to the slides to talk about that. OK, so if you recall the code that you've just seen on screen, it uses a when statement to map the route to the composable content you want to display. And with box and other composables like animated content, there's a direct mapping between the two. But in Nav3, the screen key gets mapped to an object called a nav entry, and this contains the composable content. With nav entry, we can attach additional metadata and do some other cool things, which I'll talk about later. So in short, the nav display needs a lambda that maps the key or the route to a nav entry, and this is known as an entry provider. So let me show you that in code. So let's go back here. OK, so to make this super clear, I'm just going to type the parameter here and create the lambda here. So what I'm going to do is just move this lot here inside our entry provider here and try not to mess this up. OK. And let me just pop that there. OK, so I'm just going to move that there. OK, so hopefully that's fixed that. Right, so our entry provider isn't producing composable content, it's producing nav entry instances. And it provides us with the route that we need to provide a nav entry for. So let me just add that there. OK, so the route's been provided for us. So now we can use our when statement, and all we need to do is instead of returning composable content, we just wrap this composable content in a nav entry. So let me just do that like this. And we specify the route to construct the nav entry. And I'm just going to do the same for the conversation detail section here. Nav entry route. OK, and I'll just make this a bit nicer to look at. Now, we're still seeing a lot of red code here, and this is because it's an exhaustive when, so I need to provide an else case as well. So I'm just going to cheat with a live template I created earlier, and hopefully we are working. Let's see, I put a bracket in the wrong place there. Let's just see. There's a big lag on this screen, so I'm having to figure this out as I go along. I think I'm missing another bracket there. Not that way around. Nope. Okay, what's going wrong here? Let's just try adding brackets until it compiles. Okay, right, that's the normal strategy. Okay, so that is nav3 integrated, and that's all we need to do if we can get our brackets in the right place. So the app's now running, and let's see what happens. So when we click on one of the items in the list, we get to see the conversation detail screen. So that's all worked, and a really nice feature of nav3 is you get these predictive back animations out of the box if I can trigger the gesture. Come on! There we go. Okay. So this allows you to peek to the screen behind, and you can control the amount of progress that you get by just moving your finger across the screen. So that's nav3 in a nutshell. Thanks for coming, everyone. See you later. Okay. Okay, so yay, we can navigate between two screens in a single app module. But your app is likely to be way more complex than that, with multiple modules, or at least better separation of responsibility than having all of your navigation code inside a single activity. And luckily, we've thought about how you can actually use nav3 in a more modularized environment. So, as I mentioned before, the nav display's trailing lambda is responsible for returning the nav entry associated with a given route. That's why we call it an entry provider. And using a when statement is OK if you're just creating a quick prototype. But if you look at the code, you can see there's a few repetitive tasks here. We have to check the route type each time. And we always have to create a nav entry with that same route. And we always need an else branch. This feels like boilerplate, which is why we created an entry provider DSL. And to use this, you can call entry provider, and the trailing lambda is our DSL builder. So for any of you who are familiar with Navigation 2, this is kind of how the DSL looks when you're defining your nav graph inside a nav host. So now, instead of creating nav entry objects, you can just use entry. This takes the route type as a parameter, and the trailing lambda is the composable content for that route. The route object is passed as a lambda parameter, so we can obtain any extra data from it, such as navigation arguments. And this structure comes in really handy for splitting up your entry provider, which is really useful when you have different teams managing different screens and different features. So instead of calling entry inside the entry provider builder, you can extract each one into its own extension function on the entry provider builder scope provided by the DSL. And we can move those extension functions into separate modules. You don't have to do it this way, but as in nav3 doesn't impose this structure on you, but it's just to show that it's easy to separate the nav entry creation into different features and modules. Okay, so that kind of solves how we can modularize the content for each of our screens into different feature modules, but it doesn't solve how we can navigate from one feature to another. So let's imagine we have a future version of the app where our conversation screen might want to navigate to a profile screen. And the profile screen might want to have a start conversation button, which opens a conversation screen. This requires two feature modules, conversation and profile. And these modules need to navigate to one another. So how can we implement this? Well, we can't have the feature modules depend on each other because this would create a circular dependency. Okay, so how about we hoist the navigation events into the app module? The feature modules expose parameters such as on profile clicked, here, and the app module supplies the Lambda to be run. And this is totally possible, and in fact is what we do in our main architecture sample now in Android. The problem with this approach is that it gives a lot of responsibility to the app module for wiring everything up. It also means the app module will need to be updated every time one of the feature module's navigation events change. And this can lead to merge conflicts if we have feature modules being updated independently. So you can see from the code example here, the conversation module already knows that it needs to navigate to the profile module. So why should it need the app module to implement this for it? So I would like to suggest an alternative approach. So if navigating is as easy as pushing a key onto a backstack, then all we need to do is ensure that each feature module has access to those keys or routes. Of course, the problem is, how does, in this example, the conversation module get access to the profile navigation route without depending on the profile module directly? So this recommendation should be familiar to any of you who've already worked on multi-module projects. You can create two submodules for each feature, an API module and an implementation module. The public classes, including the navigation keys and routes you want to expose for each screen, go into the API module. And data classes that are private to that feature module and all the DSL extension methods go into the implementation module. And this structure means that one feature's implementation module can depend on the other feature's API module for the screens that they need to add to the backstack, and that's without creating any circular dependencies. So let's see this in practice. Okay, so the first step here towards a kind of more scalable solution is to switch to using the DSL that I talked about. So let's see how this goes. So the first thing I need to do is call the entry provider function, and that gives us access to this DSL. And I'm going to comment this lot out because, honestly, I hate seeing all this red code. There we go. OK. Right. So we can use entry to define each of our screens. And this takes the key or the route as the type. So let's do one for conversation list. And the Lambda is just our composable content. So I can just copy that from there. And there we go. OK, and I'm just going to do the same for the conversation list, the conversation detail. Conversation detail. OK, and this gives us the route so that we can get access to any navigation arguments. So I'm just going to copy that as the composable content there. There we go. OK, and now I can get rid of all that commented code. And we have the exact same logic here with much less code. The entry provider, you might be wondering what happened to that else statement. Well, the entry provider gives us a default fallback, which we can override it if we wanted to. So hopefully you'll agree that's much clearer than it was before. So, and let's go back. So now what I can do is I can extract each one of these entries into its own extension method. So let's just do that. And I'm just going to extract it into the main activity for now. So we'll call that entry conversation list. And we'll do the same here. And I think it's M to extract. There we go, entry. OK. So now we've got these extension functions down here. We can move them into their own modules. So I've actually set up the module structure that I talked about in the slides, which was handy. So we've got our conversation feature, which has got these two submodules, API and implementation. So the first thing I'm going to do is I'm going to move the roots for the conversation feature into that module. So let's just take them out of here, pop them in here. Okay, so that's moving into API. Now what I'm going to do is I'm going to move the extension functions for those screens into the implementation module. So let's take them out of there and pop them in this one here. Okay, I need to make them public so that the main activity can get access to them. I need to fix the imports because they're coming from the API module now. So that's conversation detail, conversation list. And I think I need to fix the imports in the main activity as well. There we go. And I just fixed that one for the starting root as well. OK, so at this point, the conversation team is going to be super happy because they've got all of their screens in their own feature module. But now let's say we want to add this profile feature. And luckily, I've already prepared this in advance, and I have my own profile module over here. All I need to do is hook it up. So I've got my extension function that I can just add in here, profile entry. And what I would like to happen is, and I'll show you in the app here, when I'm on the conversation detail screen, when I click on one of the profile images, I want the profile screen to appear. So to make this happen, I need my conversation detail screen to have access to the backstack. So let's just pass in the backstack here. And I'm going to cheat a little bit and get Android Studio to fix that for me. So now my conversation detail screen has access to the backstack. And I've already got an event on that screen which I just need to hook up. OK, so all that does is when the profile image is clicked, then I'm going to create an instance of the profile root, which is in my API module there, and add it to the backstack. So that should be everything I need to do to add this new feature. So let me just rerun this and keep our fingers crossed. So what we're expecting is when we tap on the profile image, we see a new screen. There we go. So we have added a whole new feature there, and the only thing that we needed to change in the main activity was adding, hooking up, giving access to the backstack to the conversation detail screen, and adding in the actual screen into the entry provider. Now, what you might think is, OK, well, we're still going to end up with a long list of screens inside our entry provider. Well, this is normally where you'd reach for something like dependency injection. But honestly, I refuse to do a full dependency injection setup during a live coding talk. So but we do have a recipe. We have a recipes repository which shows you exactly how to do this. OK, so talking of code recipes, I'd like to just switch back to the slides to talk about some of the other design principles that we have in Navigation 3. OK, so what we heard was that Navigation 2 is kind of a bit of a black box. It provides a lot of features, but it can be difficult to customize its behavior, or specifically get access to its state. So in Nav 3, we wanted to avoid this by doing a few things differently. For common problems, we wanted to provide helpers like our entry provider DSL that are built on top of the core Nav 3 API surface, and this should make those problems more approachable. And for the more nuanced problems like dependency injection or moving your backstack out of composition and into a view model, we're focused on writing guidance on developer.android.com, as well as this repository full of recipes that show you how you might approach those problems. To be honest, we probably haven't hit the perfect balance of guidance and recipes and the built-in functionality. But this is only an alpha release at the moment, so we're really looking for feedback on how you use the library and what features are missing. So please do file bugs. We do read everything. That said, we do know that one of the things we wanted to build in from the start was scoping state at the entry level. So for normal composable functions, you would typically use the remember API to retain state between compositions. But for navigation, we need to retain the state for each screen when it's on the backstack, but it isn't visible. So remember doesn't work here. The logical API for this is remember savable, but remember savable only works if the composable using it re-enters the composition at the exact same position. And this isn't always the case with navigation. So Nav3 solves this through its nav entry decorator API. And as the name suggests, this allows nav entries to be decorated with some extra information. This is typically done by wrapping the nav entry content in another composable. So to make remember savable work as you'd expect, Nav3 ships with this decorator, which I'm not going to read out, but the main thing you need to know is, out of the box, remember savable works exactly as you would expect. So the nav entry decorator API works for you as well. So you can implement this API to create your own scoping functions. Whether that's decorating each entry with your own custom presenters, such as those provided by libraries like Molecule, or using view models. And speaking of view models, while Nav3 doesn't have any dependency on view models, we do provide a completely optional dependency in lifecycle view model navigation 3, which makes scoping view models to each individual entry a one-liner. You just need to add this view model store nav entry decorator to your nav display. So to conclude, you get save state out of the box, you get an API to help you scope everything to a nav entry, and view models are just a single line of code. So another feature we wanted to support out of the box was animations. And for this, we focused on a single question. Do you want to override the default for every screen in your app? Or do you just want to override one particular screen's animations? So to show you this, I will switch back to Android Studio. OK, so I really like the kind of slide in, slide out animation. So you've got your incoming screen coming in from the left, and your outgoing screen sliding out to the left. Sorry, into the right and out to the left. So to do this, I can just override nav display's default parameters for transitions. So let's just get that comma in there. So we can use the transition spec parameter. Now, this uses the same APIs as animated content. So anything you can do with animated content, you can do with nav display as well. So I'm going to do a slide left transition here, and I'll just fix these imports. Now, the thing about navigation is it's directional. So you can go to somewhere, and you can come back from it. And we need different animations depending on the direction that you're going. So we have another spec here, which can be used for when you go back from something. So I'll do slide right here. OK, and I just need to fix that import. OK, so let's just have a quick look to see what this looks like. Now, the emulator performance isn't great, but hopefully you can see we are now sliding in from the right and then back out to the right when we go back. OK, so that shows you how to override the defaults for every screen. Now let's look at how we can override the defaults just on an individual screen basis. So what I'd like here is when you click on the profile screen, instead of sliding in from the right, I want it to slide up from the bottom, because that's kind of it's a different feature. We might want a different user interface for it. Okay, so to do this, we can use something called metadata. So each nav entry has this metadata field that we can use to override defaults on other areas of nav3. So in this case, I'm going to override the default for the nav display transition spec. And let's just make sure I don't screw up the brackets again. Okay, so in this one, I'm going to do slide up. Okay, and I can actually chain my metadata together using plus. So I'm going to do plus nav display pop transition spec, and we'll do slide down for that. And in fact, I'm going to do the same thing. There's another transition spec that I can use for predictive back. So let's do that one, which is called predictive pop transition spec. And we'll do a slide down for that as well. Okay, so let's run that, see how it looks. Okay, so we've still got the default slide right, slide left animations for these two screens, but we should see the profile screen slide up from the bottom. There we go. And if I can initiate predictive back, get in there. There we go. And you see I get full control over that animation there. So that's how animations work in nav3. Okay, so let's just go back to the slides. And in fact, okay, sorry. Right, so I'm not normally one to point out problems with my code. There are a lot of them. But one thing we can see here is if I open up this foldable, and it doesn't have to be a foldable, this could be a tablet, or it could be, any large screen device, but the app doesn't adapt to the available window width. So to show you how we can make changes here, I would normally reach for, say, a list detail layout. But this usually requires some quite significant architectural changes. But luckily, in nav3, we kind of thought about this from the outset, and there is a simple way that we can achieve this. So we know that phones are still the #1 priority when it comes to form factors. It's common to start with a phone app and progressively enhance it by focusing on the user flows that give you the biggest return on larger screens. This is why nav3's nav display is designed to provide the best phone experience out of the box. It displays one entry at a time and supports full transition animations, as we've already seen, including system back. So our goal is that whatever you layer on top, this default will serve as a solid foundation for the majority of your users. Where it gets interesting is how we do that layering, and this is through a concept called scenes. So under the hood of nav display, a scene controls how entries are displayed. Its default behavior is to just render the last entry in the backstack in a single pane scene. But scenes can contain more than one entry. So imagine your app is running on a larger screen device and or foldable, and when it's unfolded, you want to render two nav entries side by side. You could create a two-pane scene that does this. And scenes allows you to define different layouts for different scenarios. So you can define scenes for showing a dialogue, a side-by-side list detail, a horizontal pager, or really any other layout that you need. But how does the nav display pick the correct scene to show the entries? It uses something called a scene strategy. And a scene strategy essentially asks one question: can I build a scene? If it can, it returns it. If it can't, it returns null. The nav display can receive an ordered list of scene strategies, and each one will be evaluated in turn. So if the first strategy can return a scene, then that's the one that's rendered. If not, it moves to the next strategy and does the same thing. If none of the supplied scene strategies can create a scene, then nav display always falls back to the single pane scene strategy, and the last backstack entry will be rendered in a single pane scene. So the nice thing about this API is that anyone can create scenes and scene strategies to support different layouts and device configurations. And the material team have created this list detail scene strategy. And the way that it works is it checks to see whether the window width is large enough. And if it is, it checks to see whether your nav entries have indicated whether they are list or detail screens. And if they are, then it renders them in a list detail scene. If not, then we just fall back to this single pane scene. So let's have a quick look at this in practice. I realize we're running short on time, but it should be pretty quick. OK, so all we need to do is define the strategy. So let's do strategy. And we just use, remember, list detail scene strategy. So give it the type from our backstack. And then for our nav display, we just specify this strategy when we're constructing the nav display. Now, this is essentially a no-op now because we haven't told our entries what role they play in the list detail layout. So let's just do that here. And what we can do is we can use the same metadata that we used before to override those animations. We'll just do metadata and list detail scene strategy. And we specify that as a detail pane. And I'm just going to copy that. So we can do the same down here, except that we specify a list pane. Now, list pane here has an extra argument, and we can specify a detail placeholder, which we can use for if there's no detail selected. OK, so now if we rerun this app, we've now got a list detail layout. And when we click on one of the items in the list, you'll see the detail pane appear on the right-hand side. And the really, really nice thing here is once we change our state, once we change our screen configuration, the state is still retained. So we can switch seamlessly between these different layouts without changing our navigation state. OK, so we've covered a lot, from the very basics of Nav3 through scaling up to multiple modules, adding animations, and adapting our app to support larger screens. But that's really only touching the surface of what Nav3 can do. We didn't touch on bottom navigation bars, conditional navigation, and many more use cases. So we have a repository full of these common use cases, which shows you how to use Nav3 in much more complicated scenarios. So please do take a look, and please provide feedback. Thank you very much.